All right, welcome to the second video in the Innovative Stormwater Demonstration Project at the Forest Heights Homeowners Association. If you want to know more about the project itself, you can watch the first video. If you want to know more about the practices that we might employ, there are other videos on that. This video is on stormwater. What is it? Where does it come from? How does it relate to us? So in Western Oregon and a lot of other places, Western Washington, Northwest California, from the Cascades to the coast, we have a certain rainfall pattern, and that rain doesn't matter how much comes out of the sky in an average annual year. The same sort of picture emerges about where the water goes. And so where the water goes is our water balance. This is a framework for understanding the watershed and how rainfall, where rain goes after it falls out of the sky on our land surfaces. So in a natural area, in this what we would call a pre-developed site, in Portland we get 37 inches of average annual rainfall. So 100% of that 37 inches is falling out of the sky on an average year. And a certain portion of it, studies have shown that 50% actually evaporates back up into the air. So it's captured on the structure of the trees and evaporates back up as soon as it stops raining. It might fall through the structure of the trees onto shrubs or ground cover or duff, or into that first layer of soil. And then as soon as it stops raining, the water starts to evaporate back up into the sky. If the storm is kind of more heavy, so that's a lot of our storms, right? Which is why we get such a high rate of evaporation here. But if a storm is heavier, the water might actually soak into the soil, and the trees will breathe that. It's called evapotranspiration. They'll actually suck water out of the soil and send it back up into the air, once again, as soon as it stops raining. So if the storms are even more intense than that, then they start to saturate the soils. And a percentage of our rainfall saturates the soils and starts to flow downhill. And we call this flow base flow. And that's because it's the flow that feeds our streams days, weeks, sometimes a month after a rainfall event. We'll still see water in our streams. And that's because there's all this water that's in that shallow column of soil that's just been making its way, just draining slowly but surely down into our valleys. And you see that base flow in that soil emerging as seeps or springs out of the ground sometimes. Then once a rain, maybe a storm is even bigger than that, it starts to recharge the aquifers. So we get deep infiltration. A portion of it becomes deep infiltration that goes down beyond the base flow to recharge the aquifer. And you can see here that so if we have 100% rainfall and 50% evaporation and 50% infiltration, only a very small amount of runoff becomes only a small part of our rainfall becomes runoff. So only 0.5% becomes runoff. And so what's runoff? That means everything's saturated and the water hits a piece of ground and it goes downhill over the surface. Okay, so to simplify this picture for you, here it is. We've got a forest. We have 100% of our rainfall. 50% goes back up into the air. 50% goes into the ground, and 0.5% runs off. And so this is the sort of the pie chart that we might see. And you can see that, okay, we have 100% of rainfall and we have 100.5% of water. That 0.5% is really rounding error. So if you wanted to get technical about it, then we have 49.75% evaporation, 49.75% infiltration into the soils, and then 0.5% of runoff. So kind of just a simplified picture of what our forests do and how they manage our rain. Now, we come to these forests, I came from Pennsylvania, and I said, wow, it's so beautiful here. Let's build a house. And so we do a very reasonable thing. We build a house, and we need some place to park our car, and we need some place to walk, and some place to play. So we clear that vegetation out of the way, and we cover the area in a lot of hard surfaces like roofs and driveways and sidewalks, but we still have 100% of our average annual rainfall, that 37 inches of rain a year. But now, instead of 50% evaporation, we only have 2% evaporation because water gets caught on the nooks and crannies of the pavement or the other hard surfaces, and it evaporates up. And then we have no infiltration into the soil through those hard surfaces, and that's what the gray is representing, are the hard surfaces, right? So you don't want water going through your roof and down into your basement and then into the soil. You don't want it going through your pavement. So we have no infiltration. And suddenly we went from 0.5% runoff to 98% runoff in those areas. So that's a huge, huge difference and can have a very big impact. Now, what's disappointing is that the areas that look like they're pervious, our lawn, those are actually generating a whole lot of runoff too, because we have, we don't have the incredible structure of the forest that we used to have. So we have reduced evaporation. The roots of grass only grow as deep as the grass is allowed to grow tall. So there just aren't very many roots to go down into the soil and to hold the soil from erosion, but also to evaporate water or so we're not getting a lot of evapotranspiration either. And then in our lawn areas, we get reduced infiltration because, remember, this site used to slope, and I know you guys don't have a lot of flat lots. I've been around your properties, but a lot of times, if dirt gets moved from one place to another, and there has been a lot of movement of dirt at the Forest Heights area, the engineering standard is to compact that material until it is about as dense as concrete. And so water's not getting into the soil either. And even in the areas where we haven't moved soil and asked it to live in this new place, so to speak, even the areas where we just cut the soil, those areas are either compacted, most likely compacted by the equipment that it took to build the house, or even just our foot traffic. And I'll talk more about that when we get to the soil restoration video. So a simplified picture for the for this after development picture of water balance looks a lot like this, right? We have 100% of our rain coming out of the sky, but only 2%, even, whether it's our hard surfaces or the surfaces that we perceive as being pervious, like our lawns and gardens. On average, your whole home site is looking more like this picture, where we have 98% runoff, no infiltration, very little evaporation. And so what does that mean for water quality in the streams? Well, why would it mean anything at all? It means something to the water quality in the streams because all of that water that used to go somewhere else is now going into a pipe that's directly connected to your streams. So there's what we call outfalls, and there's just this big piping network that takes all of that water and sends it down to the stream. And you can see the impact all along your streams. You can see maybe not, your streams aren't eroded to this extent, but you can see this kind of stream bank erosion all throughout your canyons. And those folks who live their properties abut the canyons, a number of them are having landslide issues because the river is rushing down in these storms and causing the land to slide, causing landslides and causing more erosion. And sediment itself is an impact to water quality. So dirt is a natural material, But dirt in excess that's suspended in the water makes it difficult for the stream life to live. And so there's a lower diversity of stream life in your canyons than there could be. And those streams all drain down to the Tualatin River, which drains out to the Willamette, which drains to the Columbia, which drains to the ocean. And so your site actually has a little part to play in all of the pollution that is throughout those waterways that I just described. So we know now that runoff from your houses, your yards, your pavements is a problem for water quality. On top of that, we find that, oh, well, in the post-developed, in this after-development state of the land, there's a whole bunch of other pollutants that might come off of your property. And so we have, from our landscape areas down there at the bottom, we have sediment and turbidity. So that's turbidity is the fine particles of dirt that get suspended and don't want to settle out. That might be coming off of a lot of the bare spots on your landscapes. And then because the soil got compacted during construction and nobody knew enough to do anything about it, it turns out that it's very difficult to get your lawn established and get your garden established. And so they may be sick, they may be prone to disease or pests. And so you end up applying a lot of fertilizers, pesticides, herbicides, and all of that runs off into the canyons, into the waterways that drain to the Tualatin River from your yards. And then the pavement, the second arrow here in the middle, are just an example of some other pollutants that might be coming from your pavement areas. So especially your driveways, you would have hydrocarbons. So those are coming off of those are oils that are coming off of your car and that you're tracking around. Heavy metals like copper, and there's a portion that's soluble and a portion that's just an actual particle. And so those two kind of have their own part to play in decreasing the quality of our water. There are other chemicals that might be on asphalt, like seal coating. And then on our roofs, we have pollutants that are maybe from the roof material itself. They might be feces from the animals, like birds and squirrels that get up there. And there's a number of pollutants that are deposited by the air. So sediment is one of those, and nutrients like nitrogen is another one of those. And so a lot of these pollutants you'll see are natural materials, especially like nitrogen. Well, what's wrong with nitrogen? It makes my plants grow. Well, what's wrong with it in the waterway when it's in excess of the natural historic levels is that it grows too much algae and it reduces the oxygen in the water, and then the stream life can't breathe, and then you have decreased diversity in the stream, and then you have decreased diversity of animals that can use the life in that stream. And then a lot of others, and of course in ponds, that kind of pollution can also reduce the benefit of recreation. So we're losing a lot of benefits. And just to help you get a handle on sediment and where it goes in a rainfall event, I put together this little slide adapted from the Pennsylvania Stormwater Best Management Practices Manual. And it shows how the total suspended solids, which is basically how much comes off of different surfaces that you might find at the Forest Heights Homeowners Association. So it's the sediment transported during a rainfall event. And you can see that rooftops actually are pretty clean. Rooftops are right here. But that lawns have a pretty high value in terms of the amount of sediment coming off of them. higher actually than a medium traffic street, and I would say a medium traffic street might be like Miller Road. So a lot of the practices that we'd like to tackle in reducing erosion and reducing the volume of runoff are practices that are in lawns. And trying to get those back to, say, planting areas would be really beneficial. And how are we going to do that? We're going to reduce runoff by using these practices called low impact development. So low impact development is a stormwater management and land development strategy applied at the parcel and subdivision scale that emphasizes conservation and use of on-site natural features integrated with engineered small-scale hydrologic controls to more closely mimic pre-development hydrologic functions. Okay, so that's a big mouthful. Let's break it down. Low-impact development is a stormwater management and land development strategy. So we're managing stormwater by improving the conditions in the built environment. We might also be, the Forest Heights Homeowners Association has been improving water quality and managing stormwater down in the canyons for a long time. But now we're going to work on the upland and the built environment. And it's a land development strategy. So actually, the fact that there are riparian corridors that run through the Forest Heights Homeowners Association property would be considered a land development strategy that's beneficial for water quality. So you already are doing things that are beneficial, and we're just expanding this family of practices to further improve water quality. So we can apply these at the parcel and subdivision scale. So lots of different scales. We're going to look at parcel as in your house property, or your condo association property, that kind of scale. We're going to look for practices that emphasize conservation and use on-site natural features, and then and maybe we're going to create more on-site natural features through the practices that we choose, and then we're going to integrate those with engineered small-scale hydrologic controls. So those are more expensive, and they're like rain gardens and porous pavement, but they can be beneficial. Because we have a challenging site, we have a pretty limited palette of engineered small-scale hydrologic controls that we're going to try to use. And then we're doing all of this to more closely mimic pre-development hydrologic functions. So remember back in the first slide I showed you a forest, and 100% of the rainfall is coming down, and 50% is going back up into the air as evaporation, and 50% is going down into the soil, and only a very small portion is running off on an average annual basis. That's the pre-development hydrologic function that we want to see.